Hi everyone, welcome to Vedantu J English. I'm Diksha, your chemistry master teacher. So everybody, let me know in the chat box if I am clearly visible and audible to all of you or not, so that we can start with this. Yes, so that we can start with this particular session of Bohr model and hydrogen spectrum. I thought there is some other thumbnail that I have accidentally put it. So let us start it, everybody. Am I visible? Am I audible to everyone or not? Shall we start? Because today's lecture is going to be very, very important. We are going to talk about Bohr model, like extremely important, right? For sure. In this chapter, if you ask me, ma'am, Bohr model and quantum theory, two major topics that are highly important for you. And the questions are not as difficult. The questions will be very simple, right? Based on formula, you will have to answer, right? Even in JEE Advanced, these topics are very important because in fusing 2-3 topics, they will ask you one question, right? But for that, you have to know the code, like all postulates of Bohr model, right? So, yes, definitely I remember you, right? So, guys, for all the students who are new here, let me introduce myself. I am Diksha and I have been BSc MS in chemistry. And guys, I have 8+ years of experience of teaching JEE aspirants, right? So, let's talk about students who have done their homework, right? So, how many of you have done bunch? Okay, thank you. So, Prajan has done the homework, Duck has done the homework, Mithil has done the homework, right? So let's talk about these. Like, what was the homework last time that I gave you? Homework was the upper stratoscope consisting of ozone layer protects us from sun's radiation that falls in the wavelength region of what? This is a factual based question, right? And this is JEE means 2019 question, okay? So that's why, right, I added this question in your homework because facts I can't teach you, facts you should remember, right? There is nothing to teach you in that, right? You should remember that this is the fact, this is the wavelength, right? So wavelength is going to be 200 to 315 wavelength, right? Okay, that much nanometer. Next is the frequency of green light is 6 into 10 raised to power 14 hertz. What is the wave number? So if you remember in the last time, what we exactly discussed was, guys, what we discussed in the last class, everybody in the chat box, what we discussed in the last class? We discussed about that here you will have, wait a minute, let me just write it here. We discussed about that here you have wave number is equals to 1 by lambda, right? They are asking you to calculate the wave number. They have given you the frequency here. Now we know that C is equals to mu lambda, right? So lambda is nothing but C by frequency. So lambda will be, so if you put this here, so it will become wave number is lambda is C frequency, C by frequency. Frequency is given to you, that is 6 into 10 raised to power 14 and this is 3 into 10 raised to power 8, right? Now what you have to do is you just have to answer this, right? After this is going to be 2, wait a minute, 2 into this frequency of green light is given as a wave number, that is 1 by lambda, right? C is equals to mu lambda, this one is C by lambda, this is 10 raised to power 8, right? Okay. So after just writing it, converting it, you will have the answer, okay? So this will be the wave number, that will be 2 into 10 raised to power 4, no, it's 6, right? 2 into 10 raised to power 6. Now the answer is 2 into 10 raised to power 6. See, this is given in hertz and we have written this also in hertz, this also in meter per second. So here answer will of wave number, that is opposite of lambda, is going to be in meter. Or first you tell me wave number. See, lambda is like length, right? So opposite of lambda will be per meter, right? So this is already ruled out, right? So either it can be per centimeter or meter. So you can see this here, this will be per meter. Now this much per meter is not possible, so you have to convert it into centimeter, right? Now what you have to do is, I think none of the answer is actually coming out to be correct here, right? None of the answer, because they are asking you the wave number, right? None of the option is actually correct. You were right. I saw this in the comment section. None of the answer is coming out to be correct here. Right? Okay? Yes. None of the option is coming out to be correct. So yes, this will be the answer here. Right? So we can just erase this here. Right? No. So now let's discuss about Bohr model. Right, everybody? Shall we start discussing about Bohr model, everybody? Yes, everyone? Now, if you talk about Bohr model, right, we discussed about quantization of electromagnetic radiation, right? We discussed that energy will be is equals to h mu. We have discussed about this, that energy will be equals to h mu, right? That is one quanta. So based on this particle nature, based on this quantization, Bohr gave his model. Now from Rutherford model, we all know that, ma'am, Rutherford, what he discussed, that this is the proton and the electrons are moving here somewhere in the circular orbits, right? Now Bohr did not give that this is moving at this particular radius, this is the velocity. That was the reason, because Bohr did not give us that this is the particular radius from where it is moving. That was the reason what happened here. That was the reason what happened here. They are moving and moving and moving and moving and moving, and they fell into the, electron will fall into the nucleus. That was thought. But in reality, this is not happening. That means there is some other theory behind it. So the theory is given by Bohr that actually it's not like it can randomly move in any circle and it will fall into the spiral path. He said that there are some discrete means there are defined orbits of of this electron. Like you have this first orbit, I'll just erase it. This is the first orbit, okay? This is the second orbit. If you see, this is the second orbit. If you see, you want to draw one more orbits here, you can draw more orbits here. Another orbit, right? So this is basically what he said, that this is the structure of atom. And in between, he said that if you talk about this, this is the nucleus that you have in between. This is the positive nucleus that you have, and the electrons are revolving in some discrete fixed circular orbits. These circular orbits have some distance from this nucleus. Let's see, N1, this is the first orbit, this will have this distance. This will have this particular distance, third distance. This is the fourth distance. So every single orbit is going to have a fixed distance from the nucleus, right? Okay. So now that's why he told you this thing. Niels Bohr was the first to explain quantitatively. That means he gave proper values, radius formula, velocity formula, all the values he gave here, right? Now what he discussed, the general feature of the structure of hydrogen atom and its spectrum. So from this theory, he will tell us about the hydrogen spectrum as well, right? So before that, you should actually learn to understand what are the postulates. Okay, everyone, let me just wear my specs because I am having too much strain. Sure, I think now it's better. I am able to see the words here, right? So postulate number 1 is, he said that the electron in the hydrogen atom can move around the nucleus in the circular path in a fixed radius. Radius is fixed, and energy, and every single orbit will have its own energy and velocity, right? These paths are called orbits, stationary states or allowed states, These orbits are arranged concentrically around the nucleus, just like I showed you. Concentrically means the one which has one center, and with that one center you make a lot of circles. That is concentrically, right? Now With this, what you need to understand is what is the formula of radius, what is the formula of velocity here. Yes, everybody, shall we do it? Everybody, shall we do it? Chal. Now, let's see what is the formula of radius here. The electron, okay, so let's see the formula of radius firstly. Now, who will tell me the formula of radius? Over here, yes, students, who will tell me the formula of radius? Wait a minute, wait a minute, wait a minute. Yes. Who will tell me the formula of radius here? Yes, ma'am. Yes, ma'am. Firstly, tell me, any one of you know the radius formula or not? Yes, students. Yes, students. I'm waiting for your answers. Yes, ma'am. Supriya is saying yes, ma'am. Beta, I'm waiting for your answers. Any one of you have any idea on radius? Shall I write it myself only then? See, if you talk about radius, radius will be formulated in two ways. That is 52.9 n square by z. Okay, that is in picometer, right? And if you talk about radius in terms of Armstrong, you can calculate 0.529 n square by z Armstrong. So I would advise you to remember it just once, right? You can also write it as r is equals to a naught n square by z, or you can also say r is directly proportional to n square by z. So these are the three formulas that you have. Okay, these are the three formulas that you have here. Now, for these three formulas, what you have to understand that radius here is given, radius here is given, radius here is given. But one thing is, ma'am, what are the different ways they can ask you the questions based on the radius, right? Let's see one question that is based on the comparison. Okay, so one by one, I'm going to write down some questions here based on the comparison, based on the like direct question, right? So with that, I'm going to ask you different kind of questions here for your practice. So first category, I'll just say case one. Okay, I'll write case one. Case one can be, they will give you directly that calculate the radius of third orbit of beryllium 3 positive ion, right? Now for Bohr model, you know, the one thing very interesting about this model was that it was only applicable for single electron species. That means you can't say that if you say hydrogen, it is applicable. For helium, take 1 electron. For lithium, take 2 electrons. For beryllium, take 3 electrons. Only when you have 1 electron, then this particular model was applicable. That's why in these questions, you will see either say hydrogen or helium or lithium or beryllium 3 positive, right? So if you see, the value of Z here is 1, Z here is 2, Z here is 3, and Z here is equals to 4. These are the values. This is Z is equals to 1, this is 2, this is 3, and that is 4. Okay, so these are the different values. Now, if you talk about this particular situation here, let's understand if in case one, they simply ask you to calculate the radius. In radius, what you need to do, you just need to write down the formula 52.9 n square by z, and the formula will become 52.9. What is n square, guys? N is third orbit, so n is given to be 3. And what is z here? Hydrogen, helium, lithium, beryllium. So z is 4, right? So z is going to be 4. So you'll write 3 square by 4. You solve it and you will have your answer here. Okay, that is going to be the answer here. Right, everybody? Right? Raja, the next lecture is not lecture, the next chapter is going to be periodic classification only. Right? After I finish this, I'll start with periodic classification only. Right? So, guys, this is how you calculate direct radius. Right? But sometimes they don't give you direct radius calculation. Sometimes they will fluctuate this. How they will fluctuate this? Let's see. Okay. Let's see. In the end, I'll also give you one question. Let's see if you're able to do the question yourself or not, right? So, in case 2, what you will have here is, everyone, what you will have here is, case 2, let's say they have given you radius of helium positive, radius of second orbit of helium positive is x. What is radius of lithium 2 positive in its third orbit? Okay. In terms of x, you have to tell this, right? So how do you solve these kind of questions with the same kind of thing, right? Okay. So let's talk about this thing here. Okay, Sai. So let's talk about this thing, radius of second orbit of helium 2 positive. So two things are given to us, right? Whenever we have to do the comparison, we always take the ratio, right? So you'll take radius of helium positive is directly proportional to n square by z, right? So radius of lithium, so you have to calculate radius of lithium. I'll write radius of lithium, the one that you have to calculate, divided by radius of helium, the one that you know. It is directly proportional to, this is directly proportional to n square by z of lithium 2 positive, and this is directly proportional to n square by z of helium positive. Okay. Now, what you have to do here is, here this is n square by z, what you will write here, for lithium 2 positive, what is the value of z? Anybody? For lithium 2 positive, the value of z is going to be 3. Orbit is given to be 3. Here orbit is given to be 2. And for helium, z is equals to 2. Right? So what I will see here, if I start calculating it, this is lithium 2 positive. This is radius of helium is nothing but x. This is going to be, for lithium both are 3. So it will be 3 square by 3. And this is 2 square by 2. 3 will cancel, 2 will cancel. And can you see, radius of lithium 2 positive is nothing but it is 3 by 2 of x. And what is x? X is nothing but radius of helium positive, right? So you will see in the answer, in the options, 1 by 2, 3 by 2, something like that will be given to you, right? Okay. So that is how you calculate in comparison of two situations. Okay. In comparison of two situations, you have to take the ratio. Any way they can mold the question and they can ask you this, right? Students, tell me if you are clear with this particular thing, that how they are going to ask you questions based on the radius, right? Okay, everyone. Let me know in the chat box over here if that is clear to you or not. If that is clear to you or not. Yes. Now, let's talk about velocity. Now, velocity questions, you will have to solve it yourself. One more question of radius is there. JEE 2025 question that says that According to Bohr model of hydrogen atom, which of the following statement is incorrect? Okay, so they are asking you the incorrect statements here, right? Do we have any slide extra where I can solve this? We need to have the slide over here, right? Let's solve this question of radius, right? Let's solve it. They have given you 4 options here. Radius of third orbit is 9 times that of first orbit. They have given you hydrogen atom. That means Z is equals to 1. Which of the following statement is incorrect, they are asking, right? So comparison is between different things here, right? See, we know that radius is directly proportional to n square by z. Z is constant here, so can I say radius is directly proportional to n square, right? So tell me one thing. Radius of third orbit, if you talk about radius of third orbit, that is going to be 3 square. That is directly 9. Radius of first orbit is 1 square. So radius of third orbit is 9 times that of first orbit. Yes, it is exactly getting 9 times. See, you can also do it like this. R is directly proportional to n square. You can also write it as is equals to a naught n square. If radius of third orbit is nothing but 9a naught, radius of first orbit is a naught, radius of 8th orbit is 8 square, that is 64a naught. Radius of 4th is 16a naught. So you can say 16, 4, 64, right? That is true. This is also correct. This is also correct. Third orbit is 9 times the first orbit. 8th orbit is 4 times the 4th orbit. That is true. What about this one? Radius of 6th orbit is 3 times. Radius of 6th orbit is 36 a naught. And this will, I don't think so, they will have any relation because they are not multiple of each other. This is 4 to 8. 1 into 3. Right? That is 2 into 2. Right? 4 into something is not 6. So that's why clearly answer third is not correct. But still, if you have to answer, radius of 4th orbit is nothing but it is 16 a naught. Are there 3 times? 16 into 3 is not 36. Right? 16 into 3 is not 36. So that means this is incorrect. Right? And they are asking you the incorrect only in JEE Mains 2025. Right? So this is the radius of 4th orbit is 4 square, that is 16 a naught, and second is 224 a naught, which is 4 times. So 4 into 4 is 16. That means this is also correct. So answer will be third is the incorrect statement. Okay, right? Clear, everybody? Is that clear? Abhijit, see, you are in 9th class right now, right? So right now just focus on understanding, right? Automatically you will learn the formulas, right? It's not that of a big deal. When you solve questions, so many questions, it's not a big deal to remember these formulas, right? These are very, very simple formulas, right? Okay? Yes. So let's talk about the next thing, that is, this is done. Students, nothing we are doing here. What I am doing is I am just comparing. R is equals to A naught. A naught is what? I have given this value A naught, right? I have given this value A naught. This is A naught, right? That means this is A naught n square by Z. Z is equals to 1, so R is equals to n square by Z, right? So R will be equals to n square multiplied by A naught because Z is equals to 1. So I am just putting the value of n here. N is given to you, third. Then I am trying to understand what is the relation and which of the following statement is incorrect, right? Okay. Now, let's talk about velocity. Okay. Let's talk about velocity. Velocity is, again, it is having a relation here that velocity is equals to 2.18 into 10 raised to power 6 Z by n meter per second. This is the formula of velocity, where we can say velocity is directly proportional to z by n. This is the full-fledged thing that you need, right? Velocity is equals to 2.18 into 10 raised to power 6 z by n. That is, it is directly proportional to z inversely to n, right? For example, similarly, they ask you questions here, and the questions are, let's say, based on two kind of questions they can ask you. So what I'll do here, I'll just copy paste the same cases here. Okay, same case I'll see, and we will see is there any difference when we talk about velocity here. Okay, same cases I'll be taking. I just want to tell you how formula change can totally change this thing. Okay, let's say they are asking you not the radius, they are asking you the velocity here, right? They are asking you the velocity, right? So how do you write the velocity here? So same way we will write the velocity. That velocity is equals to 2.18 into, this is the 10 raised to power 6 z by n. What is z? Z is 4, n is 3, and that's how you will calculate the answer in meter per second. It's that simple, right? Now, let's see this same question they have asked you in the format of velocity. Guys, tell me if that is clear or not. So silent you guys are, huh? Too much silence you maintain in the class. If the teacher says, then you ask me, ma'am, why you don't interact? Because whenever I see your chats, I don't see you saying anything, right? You just are very quiet, right? So velocity of second orbit they have given is x, and they are asking what is the velocity of lithium 2 positive, right? Or they ask you the relation between these two things, right? Okay, let's understand. Okay, let's understand. What is the formula of velocity, everybody? Velocity is directly proportional to z by n. That we know, right? So what we will write here? Okay, solve this yourself. Let me see if you are able to solve this or not. Try to solve this yourself. Yes, very good, Abhijit. Yes. Okay. So here we are going to say velocity of second orbit of helium positive, right? So velocity, let's say what we want to calculate, we will write it here. And what is already given, we will write it here. It is directly proportional to Z by N. So Z by N of lithium 2 positive. This is directly proportional to Z by N of helium positive. Now, if you see this, this is given to be velocity of lithium 2 positive divided by X is going to be, what is Z by N? What is Z here? Lithium 2 positive is this thing. Here Z is 3 and orbit number is also 3. So it is going to be 3 by 3. And here also it is going to be 2 by 2. Okay. They will cancel out each other. And what you will see, velocity of lithium 2 positive is equals to velocity of helium positive in this particular case, which is coming out to be X only. That's how with one information you can calculate for other, right? Ma'am, maintaining silence is the culture of Indian school system. Very good. Okay. Very good, very good. Do this. But don't do it too much that, you yourself will feel like what is happening. Okay? Now, let's understand the next one. Students, tell me if that is clear or not, right? Okay? Comparison velocities, if they ask you, direct formula relation, if they ask you, will you be able to do it or not? Right? Now, let's understand this particular question here that they have asked. This question is JEE Mains 2021 question that says, according to Bohr model of an atom, qualitatively, the magnitude of velocity of electron increases with decrease in positive charge on the nucleus. There is no strong hold on the electron by the nucleus. Okay, firstly, let's understand this statement. Okay, they are saying, according to Bohr model of an atom, qualitatively the magnitude of velocity, that is z by n, that is dependent on z by n, increases with increase in positive charge. Positive charge means that we are talking about which thing? Positive charge means we are talking about, everybody, which thing? Nucleus. Nucleus means atomic number. That means they are talking about Z here. Now, as Z is increasing, velocity is also increasing. So this statement is incorrect, because as Z is increasing, positive charge is increasing, then velocity is directly proportional. So this statement in itself is wrong, right? On the nucleus, as there is no strong hold the electron by the nucleus, that is also not correct. Nucleus will have a strong hold, right? So this statement is altogether incorrect. According to Bohr model of an atom, qualitatively the magnitude of velocity of electron increases with decrease in the principal quantum number. As the principal quantum number decreases, velocity increases. Yes, they have inverse relation, right? So this is true, right? So we can say statement 1 is false, statement 2 is true. So answer will be C is the correct answer. This is your 2021 latest question of JEE, right? Okay. Ma'am, why divide in the last question this? See, whenever there is comparison throughout your any physics you talk about, chemistry you talk about, mathematics you talk about, whenever something is given to us in comparison, right? Because we know this thing. We know this thing. See, if I talk about, I know that velocity of lithium is Z by N of lithium, right? Directly proportional to that. So it will be velocity of lithium is nothing but it is A naught, not A naught, this will be 2.18 into 10 raised per 6 Z by N of lithium. Similarly, it will be for helium, right? Z by N of helium. Now, we know this thing. We know this thing. This will be cancelled. We need to solve this, and we also know this. That's why we are taking the ratio, so that we can answer the value of lithium in the format of this x. We can also solve this like, ma'am, velocity of lithium is 2.18 into 10 raised to power 6. Z is what? 2, and this is what? 2. So you can also solve it like this. But they are not asking you the value here. They are asking you in comparison with this x. So I am solving the velocity of lithium in comparison with the helium. Okay, right? So whenever there is comparison, be it radius, be it velocity, be it energy, you will always do this thing, right? Okay. Now, next question is, next part is energy. So now energy has 3 formulas, guys, okay? 3 formulas of energies you have. Let us see how to learn that, okay? So first is going to be energy. Always remember it is going to be Z square by N square. So I'll tell you now 3 formulas. E is equals to minus, always it is minus, minus, and minus, okay? E is equals to minus. So this is 2.18 into 10 raised to power minus 18, right? Z square by N square. It is also 13.6 Z square by N square. It is also 1312 Z square by N square. But the units are different. Here it is joule per atom. Here it is electron volt per atom. Here it is kilojoule per mole. Okay, right? So these are the 3 formulas that will be very useful for you. Usually in energy, they ask you directly. Usually in energy, they will ask you direct numerical, that this is the orbit number, this is the atomic number, calculate the energy. They will give you calculate the energy in joule per atom, calculate the energy in kilojoule per atom, you can convert this into kilojoule, calculate the energy in electron volt per atom, calculate the energy in kilojoule per mole or joule per mole, then you will use this particular formula, right? Okay. Now, let's see question based on energy as well. This is the end part of all the formulas here that I have done, right? The energy, if you see, this is going to be equals to, energy is going to be minus 2.18 into 10 raised power minus 18. Energy is also written like energy is equals to minus 1312 into z square by n square kilojoule per mole. Okay, it is also written like this. Now you will ask me, ma'am, why it is so, right? Okay, that is a Rydberg constant that we will do. Okay, Amit, we will do that, but not now. We are not focusing on that, right? We'll do that, don't worry. What you are writing is correct, but right now we are not at that formula, right? So, we have seen this formula, we have seen this formula, right? But ma'am, what about this time period? See, simple thing is, tell me about time period. What is time? What is time? Speed is equals to distance by time, right? So time is equals to distance by speed, right? Speed is nothing but it is velocity. Distance is nothing but it is, in a circle, it is circumference, that is 2 pi r. So that means, can I say time period is directly proportional to radius and divided by velocity? Firstly, tell me, are you able to understand this? Speed is equals to distance by time. So time is equals to distance by speed. Distance is nothing but, in a circle, its circumference, that is 2 pi r, and speed is nothing but it is velocity. So from that, I can say that time period is directly proportional to radius by v. So time period is directly proportional to radius by velocity. Radius is nothing, radius is directly proportional to n square by z, and velocity is directly proportional to z by n. So that's why this becomes directly proportional to n cube by z square, and hence this is going to be the correct answer for you. This is going to be the correct answer. Tell me if that is clear. Yes, everybody? Okay. Tell me if that is clear, right? Now, let's talk about, see, this energy was nothing but it was total energy. Total energy. Let's understand, if you have to write it in terms of potential energy, in terms of kinetic energy, what you will write, okay? So, if you say total energy here, let's take it as x, okay? If you say total energy, you have calculated it as x, right? So let's say it as minus x. Then kinetic energy will be equals to plus x, and potential energy will be equals to minus of 2x. Some students, they remember it like this also, but I would advise you to remember it like that, because that's how I remember, right? So it becomes easy for you to remember it this way, right? Because total energy is x, okay? Whatever it is coming out to be, kinetic energy is going to be opposite sign of that. Potential energy is going to be same sign but double the time, okay? That is going to be your potential energy. And talking about ionization enthalpy, that is always, see, what is ionization energy? That is, we will see this in periodic classification chapter, that ionization energy is, you have an atom, you want to take out electron from there. So the energy that is required to take out electron from the outermost shell is called ionization energy. And ionization energy is energy required. So that's why here it will be positive of the, you can say, ionization energy is positive of total energy, right? That means not positive, it will be negative of total energy. Okay, negative of total energy. Total energy was minus 13.6 z square by n square. This is plus 13.6 z square by n square. Right, students? Okay, so now this is a very, very interesting graph from JEE 2025, right? Scary? Is this scary? Yes, everybody. Ma'am, how they discovered these formulas? What a question. See, everything that we are doing, we are just reading the upper layer of that. Have you seen an ocean? An ocean? So, in the ocean, what we see is just the upper layer. Ocean is very deep. Similarly, science, chemistry, these things are what you can see is, this is actually a very interesting thought that everything that we see, we find it even difficult to only study the things that they have given us. But the amount of experiments that they have done, right, is like unimaginable. So by doing experiments again and again and again and again, by having various like instruments, right, spectroscopy and all of that, then these formulas were made, right? So how he generated this formula, right? So that itself defines that how difficult it is, right? Okay? Yes. You always have this doubt. Yeah, these things are not one day. These things are not 2 days. This is the result of like so many years, right? Okay, that's why this theory is that important, right? First thing is, it's not that there is some one-page formula discussion was there, right? One notebook discussion will be there for one radius formula, right? There are so many concepts that are applied here, right? Doing assumptions, then putting that assumptions into reality. It was not like they did some experiment, they got this formula. They assume that this can be radius of any orbit. Then they applied it on various times, they failed. Then again did it again did it again failed. And doing it n number of times, then they got the formulas correctly, right? Okay. So, chalo. Let's talk about this thing, right? So for a hydrogen-like species, which of the following graphs provides the most appropriate representation of E versus Z, right? E is the energy. We know that energy is, students tell me what is energy? Energy is that how energy is variating. Energy is minus of Z square by N square. N is equals to, for hydrogen atom they are saying, so for hydrogen atom Z is equals to 1, so we can say it will be yes, it will be 1 by N square. Okay, but they are talking about Z only. Okay, wait a minute, what they are saying is for a hydrogen like species which is falling graph oh, okay. Energy of stations, that is the atomic number. Following graph provide the most appropriate representation of E versus Z plot for a constant N. If N is constant, they are telling you that if N is constant, they are saying hydrogen-like species. Okay, hydrogen-like species. Hydrogen-like means helium, lithium, beryllium, whatsoever, which has 1 electron. Okay. Now E is directly proportional to Z square by N square. Because N is constant, so that's why the variation factor is only Z. So can I say this becomes the formula? Energy is directly proportional to minus of Z square, right? Energy is directly proportional to minus of Z square. Because it's a minus, that means it is going to be on the negative side. The slope is negative, right? Simple, right? So slope is going to be negative, right? So it is definitely either this or this. This and this are ruled out because it has to be on the negative side because it is minus of Z square. Now, because it's Z square, right? So these kind of things are not straight. It would have been y is directly proportional to minus of x. Then it would have been this kind of graph, right? But now as you can see, here it is y is directly proportional to x square and that to minus. That means they are telling you about a parabolic graph here that is going downwards. And those students who are confused about the graphs, guys, I have already made a video on anti-log, log, graphs, linear graphs, non-linear graphs, all of that I have already discussed with you guys. Okay? Right? So answer is going to be B is the correct answer here, because parabolic graph will be made here, and that too negative. See, it's in your class 11th of physics, I think class 11th physics as well, parabolic graphs, right? This is the equation of that, right? Okay, so answer will be B is the correct answer here, right? Next is, let's talk about second postulate of Bohr. That was the first postulate where he told us about radius, velocities and all of that, right? Now, second postulate is the energy of an electron in the orbit does not change with time, right? It is not at all changing with time. It is changing with Z, it is changing with N, right? However, the electron, this actually he gave that Rutherford, according to Maxwell, if Rutherford was saying this is nucleus, you are moving and it will fall into the nucleus someday, right? And that's why atom is unstable. But in reality, atom is stable. So that's why he said that radius is fixed. That's why it cannot move into the spiral path, right? Second thing, he said that it will not lose energy when it is sitting in one particular orbit. If it has to lose energy, it wants to gain energy, it will have to pay for that. Okay? So let's see. This is the step. These are the stairs. Okay? These are the, okay. Let's see, these are the stairs. This is the ladder of success. Okay? Ladder of success. So this is your class 11th. This is your class 12th. Then you have, let's say you are into IIT. Then in IIT also you will have to work in like under internship. Then you will have your good 1 CR package. Why to write 1 CR? Let's write 10 CR package. Right? Okay. So now this is the ladder of success that you are working hard for. Isn't it? Now see, when you are at this level, you want to jump to this level. When you want to jump to lower to higher level, right? Do you have to lose energy or gain energy? Do you have to lessen your knowledge or gain some knowledge? You'll have to gain some knowledge. When you go from 12th to IIT, you will have to gain some knowledge. IIT to internship, you will have to work on projects. Internship to this package, you will have to showcase your skills, your speaking skills, everything, right? That's how you will land to this. This is not an easy path, not at all an easy path, right? So, to have this success ladder, if you're moving from lower energy to higher, because at this point you are at lower energy, to higher energy, you will have to gain some knowledge. That means you are gaining something. You are adding something, right? You can say gained something, right? You are moving from higher to lower. No one wants to move from higher to lower. Let's say someone is moving from higher to lower. It will be opposite of that, right? If you are moving from higher to lower, you're already on this path, you are moving to a lower path, right? So then what you have to do is, you have to lose the energy, right? Because now you have extra amount of energy that is not even required, right? So you'll have to give up on that particular energy, right? You're going to watch a movie, you are going to a movie theater, right? There you saw someone and you are like, oh my God, I'll go to this movie theater, not that movie theater, right? This movie boring, this movie interesting, I'll go to this movie theater, right? This movie you have to pay 500, this movie they're asking 1000 rupees. So you have to pay extra for that, right? 1000 rupees. Now, another situation is, you're going to this movie theater that is costing you 1000 rupees. Suddenly you saw someone entering here. You're like, oh, I don't want to be in the same theater as this person. Let's get out of this theater. I'll watch some random movie. So you are moving out of the theater. You are telling the people out there, the receptionists or the people who are giving you the tickets, you are saying that the staff, you are saying, hey, please, I want to watch this movie. Can you return my 500 rupees? So in that way, you'll have to lose the extra amount of energy. The extra 500 rupees, here it is 1000, here it is 500. So the extra 500 rupees that you don't need, you'll have to lose it, right? Okay. So similar thing is here. When you are moving from lower to higher, you will gain. When you are moving from higher to lower, then you will lose the energy. Then you will lose the energy, right? Same applies to when you talk about an atom, right? When you're going from lower orbit to higher orbit, let's say higher orbit to lower orbit, you'll have to lose energy. Lower orbit to higher orbit, you will gain the energy, right? Okay, everybody. Now, let's talk about Bohr frequency rule, right? Okay. So, if you see frequency, we know that E delta E is equals to H by H mu. Now, students, tell me one thing. When it is losing energy, it is gaining energy. In what form it is losing or gaining the energy? It is losing the energy in the form of photons. It is gaining the energy in the form of photons, right? And that is the reason what you will see that the change, that means E2 minus E1, the change in energy is equals to H mu. And this H mu is the photon frequency. Mu is frequency of the photon that is released. This H mu defines the energy of the photon that will be that it will gain or that it will lose, right? Okay. So now you can see mu will be equals to delta E divided by H. This frequency is nothing but this is the frequency of photon, right? That it is going to gain or lose, right? That is going to be delta E divided by H. That is going to be the correct answer here. And let me know in the chat box if that is clear to all of you or not, everybody. Is that clear to all of you or not, students? And how many of you have actually liked this session? No. Ma'am, we will not do it. Sure. Next is, I have to given up on even asking you for that, right? If you find that content is good, you can. If you find that content is not good, your choice, right? What I can do? Nothing. I can forcefully make you like this session, right? Okay? Yes. Okay. Lakshmi, don't worry, guys. It will take time to deliver books at your home, right? Okay? So, don't worry about that. It may be in between the process only. And what you can do is you have the Telegram channel. I hope so you are in the Telegram channel of Sigma batch, right? So what you will do in the Telegram channel, right? Just mention me your ID in the Telegram channel so that I can ask the team that how to track. Even you have the access to track your Tattva book, right? Where it is right now. Okay. So let's talk about Bohr angular momentum. Very, very important postulate. It says that MVR, that is nothing but the Bohr angular momentum, that is equals to integral multiple of h by 2 pi, where this n can be 1, it can be 2, it can be 3, it can be 4, and so on, right? So MVR is your Bohr angular momentum, that is integral multiple of h by 2 pi. Okay, thank you, Devil, but for what? Okay, so now let's talk about this particular thing here, that is JEE 2021 question on your screen. So everybody, 2021 question on your screen. Let's see how many of you will be able to answer this yourself or not. I'll be waiting for your answers. I'll give you some hint here. Kinetic energy of electron is directly proportional to z square by n square. Is it? The product of velocity and principal quantum number is V into n is directly proportional to z square. Okay. Frequency of revolution of an electron is directly proportional to z cube by n cube. Coulombic force of attraction on the electron is z cube by n4. Let's see this, which of the following is correct and which of the following is incorrect. Yes, everybody, let's watch this. Right? So first is kinetic energy of the electron is directly proportional to z square by n square. Right? That is definitely true because kinetic energy is actually equals to minus of total energy, and total energy we know that is equals to, we know that total energy is directly proportional to minus of z square by n square. So kinetic energy will be directly proportional to z square by n square. So this is the correct statement. Product of velocity. So now what is velocity? Velocity is directly proportional to z by n. Velocity multiplied by n will be directly proportional to z, not z square. So this is the incorrect. Now last two things are very important. Let's discuss that. Okay. So if you talk about the time period, this we discussed about the time period. Now wait a minute. Where should I write? Chalo. So we already discussed about the time period. Can you tell me what I told you? Time is equals to 2 pi r by velocity. We know that it will be radius by velocity. Radius was nothing but it was n square by z, and this was z and n. So it was coming out to be n cube by z square. So that's why frequency is inversely proportional to time period. This will be z square by n cube. And here what they have written is z square by, this is z cube by n cube. So this is not correct. Okay. Last is Coulombic force of attraction. Coulombic force of attraction. For this, you need to tell me from physics what is the formula of, I'll just write it down here, right? So, if you see this, guys, right, chalo, I'll just write it down here. This is also incorrect. This is also incorrect. Why the last one is correct, right? So, if you see this, here, force of attraction, right? We know that that is Q1, Q2 divided by R square. Do you remember that? Right? So, can I just put it here? Force is directly proportional to Q1, Q2 by R square. Right? Okay, tell me what is Q1? Q1, we are talking about Coulombic force of attraction on the electron. See, one will be E, one will be Z of E, Z into E. Because that is, why Z into E? Because I am talking about full-fledged nucleus. Right? Nucleus is, charge is same. See, on the proton, the charge is same as electron. But it is Z. Z is what the atomic number. So, for nitrogen, it will be 7 of proton. Right? For oxygen, it will be 8 of proton. So, that's why I have written here ZE. So, it will be directly proportional to R square. What is R? R, we know that it is directly proportional to N square by Z. So, what I'll write it here? N square, this is Z square. So, E we will not see because E is constant, right? Let's not focus over there. So, this Z and this Z, it will become Z cube, and this will become 2 into 2, this will become N4. So, that's why force of attraction is getting directly proportional to Z cube by N raised to power 4. Tell me if that is clear or not. Okay. Yes, everybody. You don't like red pen? Okay, so I'll change the color of the red pen. I've never, this is the first time I'm hearing that students are not able to understand because of the color of the pen. Brilliant, huh? So tell me, this is a very, very important point. Tell me if that is clear. If you want me to explain this again, because these 3 points you have already studied. If this point you're not able to understand, then let me know in the chat box so that I can again cover this thing. Yes, students, let me see if there is some extra page we don't have, right? Tell me, students, if that is clear or not, right? What I told you here, right? I'll just write it here, okay? So, if you see this, wait a minute, I'll just show you why the last one, okay? You're not able to understand, I'll repeat it, right? See, what is force of attraction? That is Q1, Q2 by R square. This is the Coulombic force. Now we know that this one is of electron, other is of proton, right? Proton or nucleus. Okay? So that's where this will be minus of E. This is going to be, or you can just write the mod here. This will be E, charge is E, this is Z of E. Divided by radius, we know that is N square by Z. So radius will be N square by Z whole square. So this is going to be E square Z cube by N raised to power 4. Then we can say force is directly proportional to Z cube by N raised to power 4. Okay, that is going to be the answer here. Is that clear, everybody? Right? Sanjay, Shweta, now is it clear? Tell me. Now is it clear or not? Right? Okay. I hope so. Now it is clear that why I have written it like this. And this also I told you that why time period is like that. I have also told you before also. Right? So this also I explained it. Right? This I explained it here only. This also I explained it. Right? Tell me if all the four options are clear, right? Because this is a very important question, right? This can be repeated again, right? Especially this and this point. C point and this D point can be repeated again. So answer is, which of the following is correct? A is correct and D is correct. Rest of it are wrong, right? Okay, yes. So let's talk about, next question is, according to Bohr model, angular momentum of an electron in third orbit is what? Angular momentum of an electron in the third orbit. Anybody in the chat box? Angular, crystal clear, awesome, right? So angular momentum means this is mvr, this is nh by 2 pi, right? For the third orbit means n is equals to 3 here, right? So what I'll do here, 3 by 2, this is h by pi, that is nothing but this is 1.5 h by pi, and that is going to be the correct answer. That is B is the correct answer. Okay. Now, let's do this particular question. But you know what? This question we shall do not now, right? There is some reason behind that, because here they have de Broglie's wavelength also. This we have not discussed till now. If I write the de Broglie's wavelength formula, you will ask me, ma'am, why it is so? Because we have not discussed de Broglie's hypothesis. So first we will discuss de Broglie's hypothesis. Only then, see, this is actually how they connect de Broglie's wavelength to Bohr model. This is what they have done here, right? So that's why I will not be, hello. So I will not be doing this question in today's class, because that might get confusing to you, right? Now, ratio of frequency of revolution of electron in the second excited state of helium positive and second state of hydrogen is what? Okay. Frequency ratio you have to tell in the second excited state and this. Students, tell me one thing. Mu was what? Mu was directly proportional to, it was coming out to be, I think, n cube by, we have just wrote it here, z square by n cube, okay? So, it is coming out to be, mu is directly proportional to z square by n cube, okay? Third time I am writing it here. Why it is so, I already told you, right? Okay? See, you don't need to remember force of attraction is directly proportional to what? You don't need to remember frequency. You don't need to remember time period. You should know how to calculate it. That I have told you how to calculate it, right? Remember for radius, velocity and energy. That's it. Others you'll be able to automatically generate from these three formulas. Right? Now, let's say ratio of the frequency of electron in the second orbit, second excited state. See, second, very important thing, write it here. First excited state. First excited state is what? Anybody in the chat box? First excited state is nothing, but it is it is 2. That this is the first state, excited means it is going to be 2. So first excited state is 2. Second excited state is 3. Third excited state is 4. So in this number, you just have to add 1. That is your excited state. Okay? You just have to add 1 in this particular number. So second excited state means n is equals to 3 here. Okay? Of helium, helium means Z will be equals to 2. In the second excited state of helium, in second state of hydrogen. So hydrogen means n is equals to 2. And here Z is equals to 1. Okay, so now you have to see the ratio here. Mu of helium positive by mu of hydrogen is equals to Z of Z square, Z of helium, Z of helium square, right? N of helium positive cube, right? This is, H is this, Z of hydrogen square and N of hydrogen cube. Now for hydrogen, what is the value of, for helium it is 2. It is 2 square. For hydrogen it is 1. For N for hydrogen, this is given to me, hydrogen is given to be 2 cube, and here it is given to be N for this one. Helium, where it is, 3. Okay, 3 cube. Oof. Now discuss this. Let's solve this. It is going to be 2 raised to power 5 divided by 3 cube. Okay, 2 raised to power 5 divided by 3 cube. 3 cube is 27, and that will be 2 raised to power 2. 2 into 2 is 4. I think that will be A, right? Let me just confirm it. 4 into 4 into 2. 4 for 16, 16 to 32. Yes. So answer is going to be 32 by 27. It is coming out to be the correct answer here. Okay. So based on frequency directly, they have asked you one question, and that you can easily answer. Okay. Tell me if there is any problem in the last question here. Same excited state for all. This is how it is defined, right? First excited state means from the ground we are telling first excited state is from the ground level. First excited state will be 2. Okay, so that means, okay, so I'll just write it somewhere. Let's see this. Okay, let's understand this very important thing, right? About the states, right? About the states. Let's understand this. See, if you talk about these terms here, one is ground state. One is ground state. Now, for ground state, should n be equals to 0? No, right? Ground state means n is equals to 1, right? First excited state. Here n is equals to 2. Second excited state, n is equals to 3. Third excited state, n is equals to 4. Fourth excited state, n is equals to 5. Now I'll tell you how. Okay. So let's see this. How we are going to define the excited states here. Right. So now I'm going to write this here. Let's write it down. Let's say this is n is equals to 0. N is equals to 1. That is the ground state. Right. Now, I'll also tell you why I'm writing it, why the difference is like this. So that also we'll talk about. See, This lecture is going to be now more interesting because now I'm going to not talk about the formulas. I'm going to draw these things in front of you. Okay? Okay? Now, this is n is equals to 1, this is n is equals to 2, this is n is equals to 3, this is n is equals to 4, this is n is equals to 5. Okay? Tell me if till now this is clear. Now see guys, why it is called first excited state. See, something is sitting on the ground floor. That is called ground state. If it is getting excited just once, okay, just with one step it is going upward. So that is called, after first excitation it is coming to n is equals to 2. So that's why this is called first excited state. If it goes to second excited state, that means from here it is again getting excited, so it will come towards this one, right here, right? So it is going from this to this, that is the third excited state. In reality, it is getting excited for 2 times and it is going on the third excited state. Now, again, it is moving upwards, right? Electron is going upwards. Now, this is the n is equals to 4. But this is the third transition. 1, 2, 3. So, it is third excited state. Similarly, fourth will be this one, right? So, directly also it is written like that. Okay? Right? Okay? Yes, definitely you should, right? Because you're in 9th class, for that is very important for you, right? Okay, understood? Now, why this is okay? Okay, I'll definitely ask the sir to give you physics planner. Okay, Bhanu, I'll ask the sir, right? I'll ask her to do that. Now, tell me if that is clear. Why this is called first, second, third excited state? Now, let's understand the energies here. Why here I have large gap? Why small gap? Right? There is a reason behind that, right? So if you put the energy, the value of energy is minus of 13.6. If I am talking about only the hydrogen atom, then Z is equals to 1, right? So it will be by n square, that is going to be the energy, right? Now, when I put n is equals to 1, this will be minus 13.6. When I put n is equals to 2, this will be something minus of 10. Okay. So, I'll just calculate this like properly. I'll tell you what is the energy it is coming out to be. If I put this 2, so it will be 13.6 by 4. So, 13.6 divided by 4. Sorry. So, it is coming out to be not 10 minus 3.4. The difference was 10. My bad. Right? If I put n is equals to 3 here, this will be 13.6 divided by 9. That is coming out to be minus 1.51. If I put n is equals to 4, that will be 13.6 divided by 4 into 4 is 16. That is coming out to be minus 0.85. If I put here n is equals to 5, it will be minus 13.6 divided by 5 square. That is 13.6 divided by 25, that is coming out to be minus 0.544. Can you see the difference here? Can you see this thing here? Here from minus 13.6 to minus 3.4. The gap is very large here, right? So the gap is very large. That's why here I have like drawn a large gap. Here it is getting smaller, then smaller, then smaller, then smaller. And the energy states will start overlapping with, not overlapping, but very small gap will be there, right? So can I write this here, right? Okay, can I write this here? If n is greater, if n is increasing from 1 to 2 to 3 to 4 and so on up to infinity, we are saying that it is increasing up to infinity, up to n is equals to infinity. So can I say one thing here, that if n is increasing here, in that case, the delta E value is decreasing. The gap in the energy is decreasing. Can I say that? Right? Can I say that? If I increase the value of n, can I say that the delta E, the change in the energy value is decreasing? That's a very, very, very important point, right? Next is, can you see on the number line, if you see, with a negative value. This is minus 13.6. This is minus 3.4, minus 1.5, 0.85. Can I say as n is increasing, energy is increasing with the negative sign? Okay. Can I say if n is increasing, energy is increasing? Right? Is it possible? If n is increasing here, then energy is going to increase. Yes. Right? So, what do you mean by that? When the electron is in the ground state, it is very near to nucleus. So, the attractions are very strong. As it is moving away from the nucleus, the attractions are decreasing with the nucleus. That is the reason its energy is increasing, right? Okay. So, when you are near to your family, you are like, I am the best. Like, no one can be as innocent as me. As you go to the hostel, then what you will do, you will start roaming around with your friends. You'll say, no, mom, I'm not there. I'm in some temple, right? So when you're going away from the parents, that is the nucleus, the energy is increasing. So in the same way, its energy is increasing in that way. Okay, everybody? Yes. Is that clear? Let me know in the chat box if that is clear or not. Now let's talk about Rydberg equation, right? Rydberg equation is to define 1 by lambda, that is nothing but wave number, right? That is equals to 1 by lambda is equals to RHZ square 1 by N1 square minus 1 by N2 square. Okay, that is the full formula that you need to know to understand this. Right, everybody? Let me know in the chat box if that is clear to all of you or not. Right? Okay? Let me know in the chat box, guys, if that is clear to all of you or not. Yes? So, can I say one thing? Here, ma'am, what is this RH? What is, see, lambda is wavelength. This is wave number. What is this RH? Let's understand that. RH is nothing but it's Rydberg constant, right? Now this Rydberg constant is equals to 109677 centimeter inverse, or you should also know this particular value, that 1 by Rydberg constant is equals to 912 ohms. Now the question is that, ma'am, why you are telling us two values? What's the benefit of that? See, if in the question they can ask you two things, that's why I have written two things here. If they ask you the value of lambda, now lambda and Rydberg is inversely proportional, right? So for that you should know the value of 1 by Rydberg constant, because answering 1 by 109677, it will cost you a lot of time, right? So why to learn this? Why do we need to do this, right? So that's why we are just, when we are calculating, to calculate lambda, you will use the value of Rydberg constant, right? That is 192. And in this case, lambda will be in Armstrong. The answer that you will get for lambda will be in the Armstrong. Okay. Now, if you use this particular value of Rydberg constant, right? This is to calculate, if you want to calculate wave number. Okay. Then the value of wave number will be in centimeter inverse if you put this value, right? Now, ma'am, what if in the options they are asking you it in nanometer, they are asking you this in meters? Convert it into nanometer or meter, you can easily do it. They are asking you this in per meter, right? Easily per nanometer, you can easily convert it into nanometer or meter. Okay, right? Okay. Yes, everybody. Okay. Now, let's talk about the next thing. This is done, guys. For JEE level, derivation of this is not at all important for you, right? 0% importance is for derivation for your JEE, right? Formula, what are these things? and what exactly is the application. So here always N2 should be greater than N1, right? This formula is applied where N2 is greater than N1, right? Z is defined for every atom, every single element, and Z will be different, and according to that you will apply this particular thing, right? Now, the application of this formula is very important because if you see Rydberg constant, I have already told you that in Rydberg constant, this value you can put or this value you can put. Second question is, ma'am, Z will be given in the question only, whether it's helium positive, it's lithium 2 positive, it's beryllium 3 positive, it's hydrogen atom. Based on that, you will have the value of Z. Then, ma'am, what is the value of this N1 and N2? How we will get to know about N1 and N2, right? Okay. Okay. Yes. Srinivasan, it's your choice, right? You don't want to trust, you can no. It's totally your choice, right? Okay. I am SAE. I was thinking to write this formula. Einstein came in my mind yesterday, right? He was like, okay, this is the formula to write it, so that's why I wrote it, right? No book has mentioned this ever. This is the first time we are writing this formula in this universe, right? So let's see how do you define the value of N1, right? So N1 will be defined as these 5 names, okay? These 5 names, Lyman, Balmer, Paschen, bracket, P fund. What is the names? Lyman, Balmer, Paschen, bracket, P fund. Okay? Yes, everybody? Students, everybody over here. As expected from you guys. So, it is Lyman, Balmer, Paschen, bracket, P fund. LBP, BP. Lyman, Balmer, Paschen, bracket, P fund. So, this is the value of N1. This is the value of N2. This is the region where it is lying. Okay. So, Lyman series, if you see, Lyman series, no matter from where it is traveling, it is always coming back to N1 is equals to 1. So for Lyman series, the home is N1 is equals to 1, right? So it's like whenever you go back, you go north or south, wherever you go, you will always come back to your home, right? So each of these series have a dedicated house, right? For Lyman series, N1 is 1. For Balmer, N1 is 2. For Paschen, N1 is 3. For bracket, N1 is 4. For P-fund, N1 is 5. Right? So this means that if I talk about this thing here, I'll just copy paste this thing here, right? To actually show, acha, that was written there only. So, okay, great. Right? So when I talk about Lyman series, no matter it is coming from n is equals to 2 or 3 or 4 or 5 or 6 or 7 or 8 or infinity, if it is always the ending point is n1, then these all lines are belonging to Lyman series, okay? If all the lines may be from 3 or 4 or 5 or 6 or 7 or 8 or whatever, they are coming back to n is equals to 2, that is Balmer series. All lines are coming to Paschen when n is equals to 3. All lines are coming back to n is equals to 4, that is called bracket series. All lines are coming back to n is equals to 5, that is called P-fund series. So these are the 5 series, okay? So how they can ask you the question that this particular line belongs to Lyman series. You will see that, okay, n1 is equals to 1. This particular line belongs to Balmer series. Okay, that means n1 is equals to 2, right? Or they can also variate it like this. They can also tell you this line belongs to UV region. This line belongs to visible region. So whenever it is said that it is belonging to UV region, Lyman series. Visible region, Balmer series. But they will never give you that this is belonging to infrared region, because in the infrared you have 3 things, right? So there is no hint when you talk about infrared region. So either they will mention UV region or they will mention visible region. UV means Lyman, visible means Balmer. Okay? Understood? So this is the hint for N1, what they can give you in the exam. right? Now let's talk about to calculate N2. For that, okay, let's do firstly this question here, right? Because here you don't need to understand N2. Let's do this question, 2024 JEE main question. It's the latest question. Can you see this here? Right? It's a latest question, that is Lyman series is belonging to infrared region, UV region, infrared region, visible region. Why two options are same? Okay, let's see this. See, Lyman series is belonging to UV region. So definitely one is A is 2, right? Then Balmer series is belonging to infrared, no, visible, right? Balmer series is belonging to this. Now, Paschen and P fund both are infrared region only, and both options are given to be infrared. So you'll see A4 and A2 and B4. A2 and B4. Yes, A2 and B4. This does not make any sense because the simple thing is, students, both are infrared only, right? Both are infrared only. So how will you differentiate? You can only differentiate on the basis of Lyman and Balmer, right? Differentiation can be only on the basis of Lyman and Balmer. So answer is going to be, this is the correct answer, right? Now, let's talk about next, that is, how do you answer that this, what is the value of N2? Okay, in this particular, yeah, sometimes simple question also came, na? Come. While teaching you chemistry, sometimes I forget about grammatical, like what grammatical errors I am doing, right? So, let's understand the value of N2, right? So that's how they can ask you the question for the value of N2. To understand, to calculate, uh, to understand N2 value. From the statement itself, how they will hide the N2 value somewhere, right? See, if they have given you first line, so I'll just copy paste this so that I can also teach you why we are saying this is the first line, this is the second line. Okay? Arey bhai. Wait a minute. Okay. Yes. Okay, students. So now let's understand what do you mean by first line, second line, alpha line, beta line, gamma line, shortest, longest wavelength, maximum, minimum energy, right? So let's understand. See, if they give you first line, okay? So for example, your N1 is, I'm assuming that N1 is, let's say, belonging to Lyman series. What is the first line is this one. So for first line, it will be traveling to 2. For second line, it will be traveling to 3. For third line, it will be traveling to 4. So first line is when you add 1 into N1, right? Let's say, ma'am, N1 is not 1, ma'am, N1 is 2. So first line will be this. Second line will be this. Third line will be this. Okay? So according to that, according to different N1, how you can predict your N2? So you can say that first line is nothing but it is N2 equals to N1 plus N2. Okay. First line is nothing but it is N2 equals to N1 plus N2. That is going to define the first line here. Right. So this from N2 to N1 it is going. From N2 to N1 it is going. Right. So that is the first line. So if I say, let's say you have Lyman series. You have Lyman series. What is the first line? So this is the Lyman series. This is the first line. And it is moving from N2 to N1. So this is the transition that they are telling you in the question. Okay. That's how they will say it is a Lyman series. It is the first line of Lyman series. First, see, two things they have given in first line of Lyman series. Lyman means N1 is equals to 1. first line means N2 is equals to N1 plus 1. Okay. Now, first line is also called as alpha line, right? Second line is called as beta line. Third line is called as gamma line. And what is second line? Second line is N2 is equals to N1 plus 2. Third line is N2 is equals to N1 plus 3. Similarly, fourth line will be fourth line. Then you will have fifth line, right? Similarly, fourth line will be N2 is equals to what is the fourth line, guys? N2 is equals to N1 plus N2 is equals to N1 plus 5 will be your fifth line. So that's how you will answer first line, second line, third line, fourth line. Okay. Now, this is alpha, this is beta, this is gamma, right? These are the names of the line. Beyond that, it is not there, right? Now, what do you mean by this minimum and maximum energy? Let's understand that. Students, we know that E is equals to hc by lambda, or it is h mu, right? So if I am saying that it is having minimum energy, that means this gap is minimum. This gap will be minimum if this difference is minimum, right? This gap will be minimum in the next line only, right? Here the gap will increase. So gap is minimum only in the first line. So we will say when you have minimum energy, that means we are talking about first line. When you have minimum frequency, because frequency and energy are directly proportional. So minimum frequency is also first line. Now here they can also say longest wavelength. That means if energy is minimum, lambda is going to be maximum, so it is going to be longest wavelength. So longest wavelength also means we are talking about the first line. Let's talk about this. No, this we are not talking about. Let's talk about this. Here to chalo, done. Now let's talk about limiting line. Limiting means the last line, right? So last line is belonging to n is equals to infinity. Here energy is maximum, so that's why it is written as maximum energy. That's why frequency is also maximum. Because energy is maximum, so lambda will be minimum, so it is also called as shortest wavelength, where n2 will be equals to infinity in all these cases, right? Okay. Tell me, students, this is a very, very, very important page, right? For your, yes. Students, on the Telegram channel, you will see that when is my class? Usually it is like today is Wednesday. So Wednesday 6 p.m. and Saturday 6 p.m. I have class 11 section class, right? And on Thursday 8 p.m. and Monday 8 p.m. you will see me doing class 12th chemistry. Okay? Yes? Okay. Now, let's see the next thing, that is this question of JEE Mains 2025. So what does this question say? Let's see that. Okay? Heat treatment of muscular pain involves radiations. See how they have stated. This is not even important for you, right? Don't see this like something related to heat treatment. This is related to this wavelength, right? Involves radiation of wavelength about 900 nanometer. Which spectral line of hydrogen atom is suitable for this, right? They're asking you which spectral line is actually suitable for this particular wavelength. So wavelength is given to you. Rydberg constant, you know. You need to see that what will be the value of N1 and N2 here, right? It's a very, 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 very important question. So you will apply this formula 1 by lambda is equals to RHZ square 1 by N1 square by 1 by N2 square. Okay. Now, Z is given to be 1, right? Z, we know that is given to be 1. The question is that, ma'am, what will be the value of N1 here and what will be the value of N2 here? Let's see if this is the, I think multiple answer question. Is it? where it is. No. Is it an integer based question for this? Chal, let's do this. See, lambda is given to you in nanometer, you will convert it into meter or centimeter, whatever you feel like. Now, because I want to put Rydberg constant in the terms of centimeter, so let's convert it into centimeter, right? So, approximately in centimeter, Rydberg constant is taken as 10 raised to power 5. The value that I wrote 109677, you can take it as 10 raised to power 5 approximately. Because I am writing this in centimeter per centimeter as well. That's why this also I am taking in centimeter. So now what you have is, now students, what you have is, you have this is converted, this we know, right? So we will put it over here, right? By solving this equation, where we'll solve for 1 by n1 square minus 1 by n2 square, that is coming out to be 1 by 9. Now you have to see this particular thing is possible in which of the following cases. Same thing we applied here, guys. This we know lambda, it is given Rydberg constant 10 raised to power 5 approximately. Z is given to be 1. From this, solve the value of 1 by n1 square minus 1 by n2 square. Once you solve this, then you have to do hit and trial method here, right? The condition is satisfied by here. They will give you the options A, B, C, D. I think by mistake the option are not given, right? They will give you some options in the question. Only then by putting the value of n1 and n2, the value which is giving you 1 by 9, that will be your correct answer. Okay? The value that is giving you this particular thing. Let's say they have given you n1 A option, n1 is 3, n2 is 2. Let's say in B option, n1 is 4, n2 is 1. Right? In C option, n1 is 3, n2 is infinity. In D option, n1 is 3, n2 is also, n2 is 1. Okay. So these are the 4 options that they have given you. Now, one by one, you will put all these values here, and what you will see, answer is coming out to be correct over here. So, answer will be C is the correct answer. Tell me if that is clear or not. Yes, it's completely normal, Abhijit. It's completely normal, right? Okay, tell me, students, if that is clear to everybody or not, right? This particular thing, if that is clear, you can let me know in the chat box, right? Now moving towards the next question, that is the shortest wavelength of hydrogen atom in the Lyman series is lambda 1. The longest wavelength in the Balmer series is helium positive is this. Okay, so let's solve this. See, this is also very easy to solve. Shortest wavelength, we know that the formula that we are going to apply is 1 by lambda RH Z square 1 by n1 square minus 1 by n2 square, right? Now let's talk about helium, let's talk about hydrogen atom. For hydrogen atom, what you will have, Z will be equals to 1. So you can say 1 by lambda 1, because wavelength is given to be lambda 1 for that. RH, this is shortest wavelength, right? Can you tell me, anybody? Lyman series means they are talking about that N1 here is going to be 1. Shortest wavelength means energy has to be maximum, because lambda and energy are inversely proportional. So N2 is going to be infinity here, right? So I'll put 1 by 1 square minus 1 by infinity square. This is going to be 1 by lambda 1 is equals to RH. Okay. Here what we have, longest wavelength of Balmer series, right? So this is for helium positive ion, right? Can I see for helium positive ion, what you have is Z is equals to 2. And here, N1 is given to be, what is this? Balmer means N1 is equals to 2. Longest wavelength means shortest energy. That means they are talking about the first line here. So that means N2 is equals to N1 plus 1, that is nothing but 2 plus 1, that is 3 for helium. Right? So you just put it here, lambda, they are saying let's take it as lambda 2. Lambda 2 is equals to RH. I'm not going to solve it like that. Z is given to be 2, so it will be 2 square. This is 1 by N1. What is N1, guys? N1 is 2 square minus 1 by N2, that is 3 square. Okay. So here it is going to be RH is nothing but it is 1 by lambda. It is 1 by lambda 2, 1 by lambda 1. This is 4. This is 1 by 4 minus 1 by 9. Okay. If you solve this, this will become, so I'll solve this here only. Lambda 1 by lambda 2. This is the 4 into 36. 9 minus 4 is 5. Right? So it will be 4 into this. So this will be 2 into 2. This will be 1 and 6, 8, 5 by 9. है ना? So it is coming out to be lambda 1 by lambda 2 is 5 by 9. Lambda 1 by lambda 2 is 5 by 9. Right? So lambda 2 you have to calculate. That will be 9 lambda 1 by 5. Okay. Isn't it the answer? Yes. Okay. So answer will be 9 lambda 1 by 5. So C is the correct answer here. Okay. Yes, students. Right. Shall I move ahead? Now, next question is, you have 2023. That is, which transition in hydrogen spectrum would have same wavelength as Balmer type of transition in this? Okay. So, firstly, this is comparison. Okay. So, what we will do? Firstly, we will compare the wavelength here, put the wavelength there, and then you will get the answer. So what is the wavelength here? 1 by lambda is equals to RH, right? This is Balmer wavelength has the Balmer type transition means N1 is equals to 2 from N to 4. That means this N2 is given to be 4. Okay. Directly they have given that N2 is 4. They could have also given you this is beta line, right? This is the beta line, right? So this is RH. This is for hydrogen atom. No, this is for helium atom, right? So this will be 2 square. This is 1 by N1 is 2 square. This is minus 1 by N2 is 4 square, right? So now can we just solve it here? 1 by lambda. So let's take it as lambda only. 1 by lambda is equals to RH. This is 4. This is 1 by 4 minus 1 by 16. You can keep 4 constant. Like you can take 4 outside. This will be 1 by 4. So it will cancel out. This will be RH. This is 3 by 4. So we can say 1 by lambda is equals to 3 RH by 4. Okay. This same lambda is equals to this same lambda 3 RH by 4 is equals to RH Z square. For hydrogen, Z is 1. Okay. In this, I have no idea what is the transition. They have asked me to calculate the transition. This and this will cancel out. That means we need to see in the options that thing is correct which is giving you, when you put the value of N1 and N2, if you are getting the answer as 3 by 4, that will be your correct answer. Right? Okay. Yes. Yes, everybody, that will be the correct answer. So can I say here, see from the options you will see this, because here now I think by mistake options are not written here, right? When you will see same thing that we did here, right? Same thing that we did here. Here also they will give you some options. Wait a minute, not here. Here they will give you some options and you will see which option is applicable for 1 by 9. Similarly, in this case, they will give you some options. You will put the value of N1 and N2 and then you will get the answer. Okay. Yes, everybody. Now, the last topic of today's class, which is extremely important for you and can be confusing as well. Let's see that. Okay. So, if you see this here, students, I'll just copy paste one slide because again and again making those lines is a task, right? So. Now this is one of, like, I find it very interesting. I have no idea about you. Will you find it or not? Right? So let's talk about this thing, okay? We're going to talk about this thing, not energy, not anything, right? We are simply going to talk about the number of spectral lines, okay? So this is N1 is equals to 1, N is equals to 2, N is equals to 3, N is equals to 4. Now, if someone is asking you, calculate the spectral lines, question is, calculate the number of lines from the transitions. Calculate number of lines, okay? Calculate total number of spectral lines, okay? To calculate total number of spectral lines. The transition that they have given you is, let's say it is from N is equals to 4 to, which transition do you want? See, give me some small transition because a lot of lines will be there. Because I am going to give you a direct formula after that. So you can give me a small transition for that. Let's say you have given me N is equals to 4 to 1. Okay. Now let's understand how you will see the transitions. Okay. Firstly, understand why we need formula, because this thing is weird. This thing is tough, right? Okay. Unknown, what you can do is just put it in the comment section. I'll definitely make a video on that, right? Because right now total focus is here, right? So if you see from 4 to 1, you have to make. So what I'll do, I'll just delete this line, okay? Just delete, because full focus I need. From 4 to 1, what are the possibilities? One possibility is it can firstly jump from this to this, then from this to this, then from this to this. That is the first possibility. Second possibility is, these are the three possibilities, and other can be, it will firstly jump from this to this, then it will jump from this to this, right? Next possibility can be, it will firstly jump from 4 to 3, then directly 3 to 1. Okay. Is there any other possibility, guys? Is there any other possibility? Firstly, from this to 4 to 3, then 3 to 2, then 2 to 1. Then 4 to directly 2, then 2 to 1. Then 4 to 3, then 3 to 1. Okay. Is there any other possibility here? Right? Any other possibility? 1, 2, 3, 4, 5, 6, 7. Okay. Let me see. 4 to 3, 3 to 2, 2 to 1. Then there is one more possibility. Directly it can go from 4 to 1, isn't it? Directly also it can shift from 4 to 1. Is there any other possibility? I can't see any other possibility here. Okay. So once you have written down all the possibilities possible here, same thing you have to delete. Okay. So now what you will see, this and this is same. So I'll delete one of them. This is not similar to anything. This is also not similar. This and this are same. So I'll delete one. Okay. Now can you see every single line is unique here. Every single transition is unique. 4 to 3, 3 to 2, 2 to 1. 4 to 2, 3 to 1, then 4 to this, right? So every single transition is unique. Can you see that? Can I say these are the unique spectral lines 1, 2, 3, 4, 5, 6? So number of spectral lines is going to be 6 lines here. Right? Okay. Students, the unique line that we can see is 1, 2, 3, 4, 5, 6. So between 4 and 1, we have 6 unique spectral lines that are possible. Now your question will be, ma'am, but we can easily do mistakes here. Even I can do mistake here because permutation, combination, it's very rare that you will be able to like draw all the lines, right? This is a very small transition that I have taken. What if I give you from n is equals to 10 to 2? How many spectral lines are possible? You'll be like, ma'am, it's very tough. We can't calculate. You will solve only one question in the exam, right? So for that, to make it easy for you, we have this formula. That is how you will calculate it. The formula directly is n2 minus n1, n2 minus n1 plus 1 divided by 2. So you put the value of n2 as 4. So it will be 4 minus 1. 4 minus 1 plus 1 divided by 2. And that is going to be 3 by 2 into 4. That is nothing but 6 lines. Can you see? Practically, I have showed you that how to calculate the lines, but this is not possible in the exam, right? So directly you will apply the formula and you will calculate. Okay? Yes, everybody? Right? Yes. Now, let's talk about, this is already done, right? Now, guys, let's talk about special lines. Okay? What are the lines? Special lines. Huh? What are these special lines? Okay? What if they say that they are not asking you to calculate the number of spectral lines? What if they are not asking you to calculate the number of spectral lines? But what they are asking you is for special lines. Now, what are these special lines? Let's see. Calculate number of lines from n is equals to 4 to n is equals to 2. Let's say n is equals to 1. They are saying n is equals to 4 to n is equals to 1. Which lies in Balmer region, Balmer series. Now, especially they are not saying, or they can say which lies in visible region. Let's say they say which lies in visible region. They can also say which lies in UV region, this and that they can do. Right? Now see this. From 4 to 1, there are total 6 lines. Can you tell me, like, from the lines, as you can see, which is a Lyman series line, which is a Balmer series line. So this and these 3 lines are belonging to Lyman because they are coming back to n is equals to 1. This is Lyman, right? This line is Lyman. Okay? This and this line is coming back to 2, so it will be Balmer, right? This particular line is coming back to n is equals to 3, so it will be Pasture. So can I say, out of these 6 lines, you have 1 line in Pasture, 2 lines in Balmer, but 3 lines in Lyman. Okay, can I say that? Now, ma'am, again the problem is that, ma'am, do I have to again draw the lines and then see which is Lyman, which is Balmer, which is Pasture? No, because directly the formula is n specific line is equals to n high, the higher value, that is n2, or you can say directly n2 minus n of specific. Okay? If you want to calculate the number of specific lines, let's say they ask you to calculate for Balmer, right? So n of Balmer is going to be n2 is 4, Balmer is 2, so it is going to be 2. And Lyman is going to be n2 is 4 and Lyman is 1, so it is 3, right? So n Pasture is going to be n2 is 4 and Pasture is 3, so it is going to be 1. And this particular formula will be applicable everywhere, right? Okay, everybody. Thank you. So guys, tell me if that is clear to everybody or not. right? Okay. This is a very, very important thing, and this is one of my favorite topics because it's very interesting that how we can just answer that difficult part with the help of just the formulas, right? With formulas, it automatically becomes very, very easy, right? So I think, guys, that's it for today. And let's see these two questions. That is the last two questions. That is, an electron jump from 6th energy level to 3rd energy level. How many lines belongs to visible region? See, it is going from 6th to 3rd. Let's say this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So all the lines will be between 6 and 3. All the lines will be between 6 and 3. They are asking you which will belong to visible region, which means which will fall on n is equals to 2. 0, not even one line belonging to 6 to 3 will fall on 2, because it's like you are going away from the border area. This is the border area, and this is what they are asking, that which line will fall here, how many lines will fall here. So answer will be 0 line will fall here, right? Next is the third line in the Balmer series. See what I told you, Balmer series is n1 is equals to which? 2. Third line, or they can also say gamma line. So n2 will be equals to what? N2 will be equals to n1 plus 3, that is 2 plus 3, that is 5. So transition is from n2 to n1, that is 5 to 2. So answer will be B is the correct answer here. Tell me, guys, if that is clear or not. Right? Okay. So that's it for today. And there's one more question. Yes, we have one more question. Surprisingly, I was not expecting this one. Right? Let me see how many more questions we have. Achha, we have also not done limitations. That I forgot only. I forgot about limitations, guys. I was like, that's it for today. Right? No, that's not it for today, guys. We still have the question. So this I would give you for homework, okay? The wave number of the first line of Balmer series. See, Balmer series, that means n1 is equals to 2. First line means n2 is equals to 3. We added 1. Is this much? The wave number of first line of Balmer series of this is going to be what? So you just have to solve it, right? So I'm giving you this for homework, okay? I'm giving you this for homework. I'm giving you this for homework. I know that you can easily do that, right? Yeah. So let me just put it into the homework section, right? So 3 questions, because that is a repetition of what we did, right? So that I'm giving you for homework. Same thing, Rydberg equation you have to apply and you will get your answer. Now limitations, very simple. First limitation is that what I told you, it is only applicable for single electron system. Multi-electron system it is not applicable to. Second thing is it fails to explain how you are having in the peaks when you will study NMR spectroscopy. If you get into chemistry field, then you will see doublets, triplets, these are formed, right? So how come you have doublets and triplets in the peaks of spectroscopy? That was also not explained by Bohr model, right? Then he was unable to explain Zeeman and Stark effect. Now Zeeman effect is splitting of lines, spectral lines in the presence of magnetic field. No answer for that. Then what is Stark effect is splitting off these lines in the presence of electric field. So this also he had no answer about it, why they are splitting, right? Then he had no answer that why we need to share the electrons, why we need to transfer the electrons, why there is need to make a chemical bond, why these atoms are making bonds, what is their benefit in doing that. So he was not able to explain with the help of his theory, right? Why an atom has to lose the electron and gain the electron, he was not able to explain that. then could not explain dual nature of metal and Hinsberg uncertainty principle. See, dual nature we will talk about in the next class, that is de Broglie's wavelength, and uncertainty principle also we'll talk about in the next class. What are these two things and why he was not able to explain it? That why, how can electromagnetic radiations have dual nature? How there is uncertainty principle? He was not having a reasoning for the uncertainty principle. And these two things we'll study in the next class, right? So now homework number 1 is, guys, this is the question number 1, right? Question number 1, guys. Then this is question number 2, right? I have already given you hint directly for Rydberg equation. And this is question number 3, that is Balmer series appears in which region? Okay, so this also you can easily answer, right? Okay, so I hope so. Everything is clear to you. This is our JEE Vedantu JEE official Telegram channel. And guys, I would love to see your comments and homework in the comment section. And if you see here, this is our pro course, right? For all the JEE 2027 aspirants, you can click on here. In this course, this is a 2 years course where live sessions, mentor, dedicated mentor will be provided to you, who will be looking at you whether you are solving the questions or not. There will be no distractions, nothing, no nuisance will be treated in, like, will be, you know, taken, like, no nuisance will be there in the batch. It's not like some student is bullying you and we will tolerate that. Though no nuisance will be tolerated in the batch, so don't worry about that, right? Full safety will be provided to you even if your video call is on, right? We'll be able to see that whether you are studying or not. The teacher will be able to see this, and we will provide you the mock test. We'll provide you the Vedantu Tattva books that will be delivered at your home. And students, along with that, you have this 24/7 live video call doubt solving, right? So any time of the day, be it 2 a.m., 2 p.m., you will be able to solve the questions on the video call with the teacher, right? So all these things are provided to you. You can go and view course plans, and according to that, you can see your Vedantu Pro course, right? So it is just like an offline experience, but sitting at your home. Because we'll be able to see you, you will be able to see, you will be able to talk to us over the mic, that is unmuting you and talking to you. You'll be able to ask your doubts 24/7, right? Then mock tests, these Tattva books, everything will be provided to you, right? Okay, yes. Yes, definitely. Level 1 to level 4, all kind of questions you should solve. Okay, sure. Okay then guys, bye-bye. Take care. See you all in the next class. I'm waiting for your homeworks in the comment section. Let's see how many of you do that. Till then, bye-bye.